Hello, it's Saif Ahmed, and I'm going to integrate this equation using integration by substitution. To integrate by substitution or u substitution, we should first choose a u, and I'm going to choose cotan x for this example, and find its derivative. And we know it's negative cosecant squared x. Now we should replace the u and the dx in the original equation to integrate. Let's replace them. The cotan x will be u, the cosecant squared x will stay here, and the dx will be du over negative cosecant. Negative du over cosecant squared x. This cosecant will cancel with this one, and we will stay with negative the integration of square root of u du. Now it's easy to integrate this one, as it will be u to the power half du. We'll add 1 to the half and divide by it to integrate. So it will be negative u to the power 1.5 divided by 1.5, and we should add the constant c. Now we replace the u in the equation, and the u is cotan x. So cotan x to the power 1.5 divided by 1.5 plus c. This is the final integration of square root of cotan x cosecant squared x dx equals negative cotan x to the power 1.5 over 1.5 plus c.
Now we will solve a question about integration by substitution. First of all, what is integration by substitution? It is a method to find the integral. Now I will show you what is the method. The method, the first step, you need to find the u. In this case, you need to choose it. So in this case, I will just choose u to be equal to x squared minus 5. The second step, find dx. So du over dx, or the derivative of u, will be equal to 2x. So dx is equal to du over 2x. In the third step, change it to be in terms of u. So it would be 3x over u times du over 2x. In this case, x will go with x, and we will be left with integral of 3 over 2 du over u. And last step, we just need to solve it and change it back to be in terms of the original variable. Since the 3 over 2 is constant, it will be 3 over 2 outside, and du over u, oh sorry, here dx, also here dx. The du over u would be what? Would be ln of u plus c. So 3 over 2 times ln of u plus c. Change it. 3 over 2 times ln of x squared minus 5 plus c. Now we solve this question using integration by substitution.
My name is Maid. Today we'll talk about or we will discuss about the u substitution. First thing, we substitute any function by u. Then from u we get the du over dx. Then we substitute we get the dx equal the du over the derivative of the function. Okay. and then we solve that, we integrate the function, and from that we we get the integration. After that, if we have any boundaries, we substitute the boundaries and we subtract and like that. And if we don't have, we substitute again the function again after the integration. Okay, we will try an example now. Okay, now we have this integration, this example of integration. Now we have to integrate, and we have to use integration by substitution. We have here x squared minus 5. We put the u equal x squared minus 5. We get the du equals 2x over dx. From here we get the dx equal du over 2x. Okay, here then we substitute 3x over u, and here du over 2x. X goes with x. Here 3 over 2 out, and here 1 over u du. We know that 1 over u is ln u, and here we have 3 over 2, and now we come back to the function x squared minus 5. Here 3 over 2 ln x squared minus 5, and that's the answer.
Hi, Assalamu alaikum. I'm Mohammed Abed, and today I will be solving the questions for the system-wide quiz homework. I will be solving first all the free response questions related to the objective of integration by substitution. The first question is: a particle moves along the x-axis so that its velocity at t greater than 0 is given by vt, t equal brackets t squared minus 4 cubed. Find the total distance traveled from t0 to t3. We know that x of t, especially for total distance, is equal to the integration of absolute value of vt dt. So we need to find the zeros of the equation since it's the total distance. So we just t minus 4, okay. We just equal it to 0. Then we will be having t equal 0 and t equal 2, which means 0 to 2. But now we need to find the negative and the positive value, the positive and which one is positive and which one is negative from 0 to 2 and 0 to 3. So we'll just substitute the a number between 0 and 2 in the equation to see if it's negative or positive, and same as this one. If we substitute it here 1, we will get a negative number. So it will be for the total distance is equal to negative, since from 0 to 2 gave us a negative number when we substitute a number between them. Integration from 0 to 2 t squared minus 4 cubed dt plus from since from 0 to 3 we cannot write 0 to 3, so we will continue from 2. So 2 to 3, the same function. Since the objective of this question is integration by substitution and problems related to acceleration, velocity, and displacement, so we will use the integration by substitution, where our u will be t squared minus 4, which means du over dt is 2t, and our dt is du over 2t. Now we will substitute the u instead of this one in both equations. So total distance is equal to minus from 0 to 2 t, and here u cubed. Instead of dt you will put du over 2t plus from 2 to 3 t, and here u cubed. Instead also of dt you would have du over 2t. Here half and here also half, so I'll take half outside for both sides, minus half integration from 0 to 2, and also we have here t, so it will be easy to cancel. So it will be u cubed times du plus half, since we took the half outside, u integration from 2 to 3, u cubed times du. And now the easiest part is to find the integration, which is a kid's step. Minus half, we just add 1 to the power, which is 4, divided by the number 4, from 0 to 2, and then plus again the same thing, half, and the integration here is also the same thing, u power 4 divided by 4 from 2 to 3. After substituting the numbers, we will get or let's do by steps, so no extra questions asked later why we jumped on this step. So it will be minus half times 2 power 4 over 4 minus 0 of 4 divided by 4 plus half times 3 power 4 over 4 minus 2 often 4 divided by 4. Then we will get 32 plus 625 divided by 8, which is equal to 110.125. This is for the first question, for the first objective, which is integration by substitution, which is question 13. Now we will go to question 16, which is also the same thing, by solving by integration by substitution. It's easy. We will consider every time, mostly in the questions that have square root, consider the value which is under the square root as u. So we consider u is cotan x, where its derivative is minus, in this case we use here x. Okay, so it will be minus cosecant squared x, and the dx is du divided by minus cosecant squared x. So let's now substitute. Integration of square root of u times cosecant squared x times du over minus cosecant squared x. Now we can cancel the cosecant squared, and the minus we can take it outside. So it will be minus integration of square root of u times du, and the integration of u power half times du. Now we do the simple integration calculation, which is minus and then add 1 to the power, which is 3 over 2. So u of 3 over 2 divided by 3 over 2. Yeah, this is it. And plus c. And now we substitute the u, which is cosine x. So the integration of square root of cosine x times cosecant squared x times dx is minus, which one's u, is cosine x with the power 3 over 2 divided by 3 over 2 plus c. This is for the second question. Now let's move to the other question, which is question 17, the same thing. Here we use the denominator as u, which is easier. So u is equal to x squared minus 5. Du over dx is equal to 2x. And the dx will be equal to du over 2x. And now let's substitute the u. Integration of 3x divided by u dx, instead of dx will be du over 2x. So what we'll do now, the x and x will be cancelled, and the 3 over 2 will be taken outside. So 3 over 2 integration of 1 over u times du, which is ln u. So 3 over 2, the integration of 1 over u is ln u plus c. And now we can substitute the u, ln over 2, ln, the u is x squared minus 5, so x squared minus 5 plus c. This is for the third first ones. They're related to integration by substitution. Let's go now to question number 20, which is the last one for the integration by substitution. So let's solve the initial problem. Dy over dx equal to 4 square root of ln y, square root of y, ln x over x, when y is equal to 1 and x equal to e. First, we know that we need to separate the dy with the y and the dx with the x. So what we will do here is make the dy, we will swap here. We'll take the square root of y here and the dx up over square root of y equal to 4 ln x over x, and here dx. Now we make the integration for both sides. So integration here and integration here. So after making the integration for both sides, we will get here 2 square root of y equal to 4 ln x squared over 2 plus c. So here it will become 2. So 2 square root of y, sorry, the 2 which is from here, so cancelled. It will become 2, I'm so sorry, 1 minute. It's 2 square root of y equal to 4 ln x squared over 2 plus c. This will become 2, and then again we will divide, but we will cancel the 2 again. So square root of y is equal to ln x squared plus c. So they give us the y and the x to know the value of c. So square root of y is 1 equal to ln, what's x? E squared plus c. Then c will be equal to 1 minus 1, which is 0. So square root of y is equal to ln x squared plus 0 and then we'll take the square root for both sides, so we can cancel the square root here. So square root here, square root here. Y will be equal to ln x power 4. This is the equation. And by this we finished all the questions for free response related to the integration by substitution. There are some questions that's repeated for other objectives. For example, question 20, 13, question 20 and 13 for the objectives of solving differential equation. And for question 20 is solving differential equation, and for 13 is also both integration by substitution and problems related to acceleration, velocity, and differential displacement and distance. So it will not be repeated a second time since it's solved for both parts. And wait for the second part to solve the integration by parts. Welcome to the multiple choice solving in details for the system-wide quiz homework punishment using the system-wide quiz term 2 exam. First objective is integration by substitution. We classify the question that is talking about this lesson. So we have question 1, 2, 5, and 9. Let's start by solving 1. We need to find the integral from 1 to 2 dx over 2x plus 1 by using substitution. U is 2x plus 1. So dx is equal to du over the derivative of this, which is 2. Which means now when we substitute integration from 1 to 2, 1 over u times the dx du over 2, which means half integration from 1 to 2, 1 du over u, which means half ln of u from 1 to 2, which means half ln of what's u, 2, what's x, first 2 plus 1 minus ln of 2 times 1 plus 1, which means half ln of 4, 5 minus ln of 3, which is e. Now let's solve the second equation, which is square root the integration from this to this, this to this. They give us already that u is sine 2x, so du will be equal, du over dx will be equal to cosine of 2x. Sorry for the pausing, let's continue. It's 2 cosine 2x, so dx is equal to du over, du over 2 cosine 2x. And since it's u, the limits will definitely change. The limits will be changing. So we'll substitute pi over 6 in this and pi over 2 in this. So after substituting in the calculator, the new limits will be from square root of 3 over 2 to 0. And of course this is u, so u power 5 times cosine 2x times dx is du over 2 cosine 2x. These will cancel and the half will be outside, so half integration from square root of 3 over 2 to 0, u power 5 times du, so half u 6 over 6 from square root of 3 over 2 to 0. And then here we have half from what's u? U is sine 2x to be power also 6 over 6 from square root of 3 over 2 to 0, where then it will become D. Now let's go to the third question. Let's consider this one as u. So u is equal to 2x power 4 minus 4x plus 3. Du over dx is equal to 8x cubed minus 4. dx is equal to du 8x cubed minus 4. Now let's substitute them easily. Square root integration of 2x cubed minus 1 times u power 7 times du over 8 cubed minus 4. D eight cubed with the other one here it will be cancelling. One moment please. And sorry for the time that we paused. So we continue. 2x cubed minus 1 times u power 7 du. So we can cancel from these two. We use the greatest common factor, which is taking 4 outside, and 2x cubed minus 1. It's the same as this one, so we can cancel here, cancel. And 1 over 4, we can take it outside, 1 over 4 integration u 7 du. u 1 over 4, sorry, u 8 plus c. 1 over 4 is u. Let's make it here now, since it's by 4, so times 2x power 4 minus 4x plus 3, all of them power 8 plus c, which gives us the answer of part A. They want us to find from these 4 choices which one is true. So what we will do is check each and every one of them. When it's here only x or t, when we substitute the 6 here, it will give us 18, and we substitute the 9 here, 27, while the limit's 18 to 27, that's correct. Same as this one, but not 36, so it's wrong. And then we'll check for the second one, where we should substitute 12 in this place, so we know it's equals to what? So 3 times 12 is equal to 36. So 3 times 12 36 is correct. And the limit, when we substitute here 18, that's correct. And substitute the 9 here, 27. So choice A is the correct one.
I will solve this question using integration by substitution. First of all, we will consider this as u. And its derivative will be 2 dx, which will give us dx is equal to du over 2. So it will be the integral from 1
to 2 du over u, and we will take 1 over 2 outside here. Then the integral of du over u is ln u u is 2x plus 1, so it will be 1 over 2 then 2x plus 1 from 1 to 2. Then we will substitute these two numbers on x, so it will be 1 over 2 ln 2 times 2 plus 1 minus ln 2 times 1 plus 1 to be 1 over 2 times ln 5 minus ln 3, which is E.
The objective use substitution methods to evaluate antiderivatives. Question 13 from the system-wide quiz paper is to find the distance from the given function Vt equals to t open bracket t squared minus 4 close bracket to the power of 3. First, we need to find the zero to see where it's positive and negative. We found two zeros, and the function is from 0 to 2 is negative, and from 2 to 3 is positive. That's for the first step. Then we create the integration from 0 to 2 and the given function dt plus 2 to 3. Since it's from here it's negative and here it's positive, we use a u substitution. U equals to t squared minus 4 and du equals to 2t dt. Then we substitute the variables with the function. Negative half integration from 0 to u to the power of 3 2t plus half the integration from 2 to 3 the interval u cubed 2t dt. Then as we evaluated negative half from 0 to 4, we found 0 to 4 by substituting the numbers in the function that we found, which is u equals to t squared minus 4 plus half u cubed du, which equals to 1 over 8 u cubed this plus 1 over 8 4 to the power of 4 from the interval 5 to 0. The answer is 110.125.